is where functions are increasing or decreasing. Some of you, in fact, I just did this recently with my present fifth form who are doing further maths, but obviously I'm conscious of the fact a number of you didn't do further maths. But also it may be that even those of you who were doing it didn't get around to this because obviously we went into lockdown 1. Anyway, this is pretty straightforward either way. So increasing and decreasing functions. Now don't overcomplicate this. A function is increasing if it's going uphill, left to right. End of story. Okay, so that first graph, that is increasing for all values of x. Okay, the rate of increase might change. All right, you know, it's increasing at a faster rate here and slower rate there. But at the end of the day, that is an increasing function throughout because it is permanently going upwards. Whereas the second W-shaped one, obviously that is decreasing down to the x value, down to the value of -1. It's increasing between -1 and 0, decreasing between 0 and 1, and increasing by -1 onwards. So it's either just where it's going up or down. Okay, couldn't be simpler really. So that's the definition of it. So if you're actually given the graph, you just can't, you're laughing, aren't you? Because you just literally see where it's going up or down. Much more likely is they'll just give you an equation and you have to do it from that. So let's say we've been given in this example 12 this cubic graph here. Okay, show that the function blah 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 is increasing for all of x. So if it's increasing, it's going to have a positive gradient. Okay, it's going uphill. So let's differentiate it. So let's go and work out f dash x. So when we go and differentiate this, remember you multiply by the current power, reduce the power by 1, we get 3x squared plus 24. Now, at that point, remember, whenever you square anything, it becomes positive. So by definition, x squared is positive, timesing it by 3 is positive, and adding another 24 is making it even more positive. So having differentiated this one here, because of the x squared component and no other reference to x's, you can just conclude x squared is greater than or equal to 0 for all values, real values of x. So therefore, blah, blah, blah. It's increasing for all the real values of x. Okay, so question 13. Find the interval in which the function, this cubic, is decreasing. So start off by differentiating it, and we get 3x squared plus 6x minus 9. Now it's decreasing when the gradient is less than 0. Okay, so we want this to be less than 0. I'm not quite sure where it says less than or equal to. Not sure I like that, because I think when it equals 0, it's not increasing or decreasing. Anyway, so having differentiated it, let's divide through by 3 and factorize it, and we can see when is this going to give us a negative result. Now just think about these brackets here. When x is greater than or equal to -3 or less than or equal to 1. So let's just think about that. So we've got to think about the three different regions. So I think I might just do a quick sketch here to help me gather my thoughts. So we've got our solutions at x being -3 and x being +1. It is a positive gradient. It's a positive. So what I'm sketching here is the differential. Okay, so it's going down. Where is it going down? It's going down. So where x is between 1 and -3. Yes. So yes. Let me gather my. Remember, this is not a sketch of the curve itself. Okay. The curve itself is looking like this. All right. It is a cubic. This one I've drawn on the left is the differential, and we're just looking where it is less than 0, where it is less than 0. Okay, so where is the differential less than naught, well, it's between -1 and -3 and 1. So what we're saying is between -3 and 1 would represent that little bit on the curve itself. Okay, I'm not convinced about the greater than or equal to -3 and the less than or equal to bit. I'm not too keen on the equal sign being included, but I'll give that some thought. Okay, but just so we're clear here, because I think I confuse things a bit. It is a cubic graph, so the one on the right-hand side is how it actually looks. We're looking for where it's a decreasing function, this bit here in green on the right. Okay, by having by plotting the differential, whereas the differential less than naught is between these values here, so that represents that little bit of the curve. I hope that's clear. And then we are into exercise 12G. Okay, so that's what we're going to do today. It's not that long, it's only 4 questions long, but obviously there's got some quite significant bits to 1 and 2. So what I would suggest we do, I'd want to make sure we have time to get on to 3 and 4, because they're exam standard. So why don't we just dot around with numbers 1? Let's just for questions 1 and 2, let's for now just do the odds. So let's do A, C, E, and G. And similarly, when we get on to question 2, let's do the same. Let's do A, C, E, and G. And then so that's just 4 bits there. And then when we get on to question 3 and 4, and they're not long, but if we could just do those, try and make sure we get those done in the hour, that would be great. So what I'm going to do now, I'm going to stop the recording, and then obviously once that stops, you're welcome to unmute if you want, if you've got any queries, or you can have your camera, you can have